Without a doubt, the easiest way to access dictionaries is to find an existing one that has been developed by another researchers, and Google Scholar is a useful resource for that. But you have to be aware of several potential inconveniences. First, the dictionary may not perfectly match your own research objective. You also have to consider for what type of data it has been developed for, and what is the theory behind, and how it has been validated, if it has been validated at all. The second strategy is trying to use your brain and maybe some resources to identify synonyms. It is very difficult, if not impossible, for anybody to generate a comprehensive list of words representing a specific concept. Using a thesaurus seems like a good idea, yet there are two major issues with this. First, you will likely have a lot of words that may never be used in the document you will analyze. But also, thesaurus contain typically a lot of words, but very few phrases and idioms, those that are less ambiguous than single words. What I would like to focus on today is a situation where you have access to some text data that has been either classified or categorized, and how you can use such text resources to support the work of dictionary development. And I will give you three different examples. The first one is a content analysis dictionary that is currently being developed by Brian Gerard to measure Myers-Briggs personality type, which consists of 4 binary preferences, which combined together generate 16 personality types. Several textbooks on this theory contain distinct sections describing separately each of those 16 types. Together they represent 8 examples of each preference, 8 introversion, 8 extraversion, etc. The author extracted those descriptions from several textbooks and used this dataset to identify words and idioms associated with those. He did use some thesaurus to expand the vocabulary, ask experts to review those additional entries, and he also expects to use real clinical description in later phrases. What is interesting with this approach is that the clinical description were used not only as a source to identify words and phrases, but it also serves as a validation method. If the dictionary can correctly classify all 16 types, then chances are that it will also work on similar description. My second example comes from a recent consultation we did with Catherine Larouche and her team, who developed a typology of 7 conceptions of universities, and they wanted to create a dictionary that could be used to measure those 7 conceptions. They collected 192 annual reports, mission statements, web pages from 130 colleges and universities across Canada, split those documents into about 23,000 paragraphs and code them manually. They came to me with the following spreadsheet of text segments with all codes stored in a single column. I transformed this column into 7 binomial, each one corresponding to one conception. The conceptions were not mutually exclusive. A single paragraph could contain more than one conception. We extracted the most frequent phrases of 2 to 5 words and compute for each of those their point behavioral correlation with each binary variable. We could as well use other association metrics such as TOB, TOC, or an asymmetric summary D. My own recommendation would be to use Goodman-Kruskal gamma, since it separates more clearly those two conditions. You then sort phrases in descending order of the chosen statistics. The most relevant phrase should appear at the top of the list. You then simply have to select those that you believe are relevant and add them to the associated category. Once you have done this with phrases, you do the same with leftover words. What I mean by leftover words is all words that are not part of the phrase that has been selected up until now. Now, if rather than having 7 independent dimensions that could be transformed into 7 binary variables, you have 7 mutually exclusive categories. This is how it would look like. You could of course apply correspondence analysis that could give you some indication about which words or phrases are associated with which category, but beyond 3 or 4 categories it becomes quite difficult to extract relevant information. A more useful way would be to perform a cross-tabulation on each item on a multinomial variable, compute chi-square residual. You could then sort all phrases in descending order of the statistics for each value of the multinomial variable, allowing you to identify the words associated with each value. We implemented something like this in WordStat in the deviation table feature, allowing you to easily identify characteristics of specific value of a multinomial variable. The problem with such an approach is that it is typically less sensitive than prior approach using multiple binomial variables. Categories may be mutually exclusive, but they are not necessarily equally apart from each other, and 2 somehow related categories may be more difficult to differentiate this way. This is the reason why I suggest that even if you have a multinomial variable, to transform it into multiple binomials. and proceed like I've shown before. One important benefit of such a dataset is that not only it provides assistance in identifying items for the dictionary as a way to validate the dictionary entries, but it also allows you to identify false negative or all paragraphs that are not covered by your dictionary. See where they occur, and by focusing on those text segments, try to identify new entries, new rules to increase the sensitivity of your dictionary. Now, the third example that I would like to share with you is how we use an external dataset to customize an existing dictionary. Sentiment analysis is very popular, and while there are many existing lexicons and dictionaries and tools for sentiment analysis, they are accurate only under the condition that they have been customized to a specific domain. A couple of years ago, we want to demonstrate how to customize a general sentiment dictionary to a specific domain and a specific context in order to improve its accuracy. We did this on reviews of tens of thousands of beauty products purchased online. And one problem was that in a single review, it may contain positive and negative comments. So ideally, we would manually tag those reviews to identify what was positive and what was negative. But this would have taken us quite a lot of time. So we decided instead to select only reviews with 1 or 2 stars and those with a perfect score of 5 stars. We ended up with 10,000 quite negative and 10,000 strongly positive reviews. The first task was to validate existing dictionary entries. We need to remove any words that were not necessarily positive or negative, but were about the product, the service, the company. We also wanted to see whether there were any entries predicting the wrong results. For example, a negative words that predict positive sentiment or the reverse. To do that, we analyze words categorized as negative first, but yielding either null or positive correlation with satisfaction score. We then look at all the words that are categorized as positive in the dictionary, yet yielding either null or negative correlation with satisfaction. We quickly identified a clear bias in our general sentiment dictionary, and we realized that one of the main functions of beauty product is to hide imperfection. All reference to those imperfections and the ideas of hiding, decreasing, reducing those had to be removed from the negative lexicons. Here are just some examples of those words that we remove. We also found several negative words that were actually related to the instruction on how the product should be applied, with words like drop, wipe, remove, routine, strokes, etc. So we had to remove them as well. We did the same process with positive words and got some interesting results. For example, the word proof is associated with waterproof, sweatproof, which are normally features of the product, not necessarily positive or negative. Star, also with no S, was also very highly correlated with negative sentiment. Earning a star in school or being the star of the show may be positive, but giving only 1 star on Amazon is not positive, right? An even more interesting word was skeptic, which was possibly related to satisfaction. A keyword in context helped us understand that clients were often skeptical about the virtues of product announced on the web. We found a lot of I was skeptic, often followed by but. Okay, while skeptic by itself may be considered negative, if the objective is to predict sentiment, then skeptic clearly belongs to the list of positive words, strangely enough. After cleaning the existing dictionary, the next task was to identify new words that could be added to the dictionary in order to better predict sentiment. To achieve this, we analyzed the most frequent words not already in the dictionary and see those positively or negatively related to satisfaction score. Here are some examples of words that were not in the initial dictionary but were quickly identified as negative. Several of those were related to the product properties like its appearance, texture, smell, or defect. Another interesting categories of words were related to the context of online orders and communication with customer support with reference to warranty, to return, to calls, contacted. That would normally be considered neutral but were predicting dissatisfaction in the context of online orders. Finally, another interesting categories of words that we were not expecting are reference to the marketing of those products. It appeared that when people refer to the advertising, the picture, the photo, or the description of the product, it is most of the time to complain about the discrepancy between what was advertised and what they received. So they were, in a sense, predicting negative sentiment. Here are some examples of words that were not in our initial sentiment dictionary, but in the context of beauty product may be considered positive. After this process, we measured the accuracy of the sentiment dictionary on a new dataset, and we found that we moved from an accuracy score of 74%, which is decent compared to other dictionaries and other tools, to more than 83%, clearly above all the other sentiment tools we tested. To summarize what I would consider the benefit of using categorized or tagged documents when you build dictionaries, I would say that the main one is to assist you identifying words and idiom to measure the categories you want to measure. It also provides a way to assess the accuracy of your dictionary by applying it and try to see whether if it detects those items that have been categorized. It also helps you increase the sensitivity by allowing you to identify false negative. It may also be used to customize an existing dictionary to a specific context of application by finding flaws, errors, and omission. But it also will help you discover unexpected outcomes, things that would be counterintuitive or things that would be indirect evidence of what you're looking for, not necessarily direct but indirect evidence. Thank you.